and a very warm welcome to this second session of the day on bias and fairness in AI systems. Before we proceed, allow me to briefly introduce today's resource person, Dr. Arun Solanki. Dr. Arun Solanki is an assistant professor in the Department of Computer Science and Engineering at the University School of Information and Communication Technology, Gautam Buddha University, Greater Noida. He is also the co-convener of the Center of Excellence in Artificial Intelligence. Dr. Solanki has a diverse background, having served in various capacities within the university. He has done his PhD in Computer Science and Engineering from Gautam Buddha University. Dr. Solanki has supervised more than 70 MTech dissertations as he is currently guiding 5 PhD students in the area of artificial intelligence. His research interests are broad and include expert systems, machine learning, and search engines. Dr. Solanki has published over 70 research articles in a Scopus Indexed or UGC Care journals. Dr. Solanki has organized several faculty development programs, conferences, workshops, and seminars, and has chaired many sessions at international conferences and national conferences. He is teaching currently an associate editor for the International Journal of Web-Based Learning and Teaching Technologies, published by IGI Global, and has worked as a guest editor for a special issue in the journal Recent Patents on Computer Science by Bentham Science Publishers. In addition to his editorial roles, Dr. Solanki has published more than 10 books with renowned publishers like IGI Global, CRC, Elsevier, He also served as a reviewer for several high-impact journals from publishers like Springer, IGI Global, and Elsevier, etc. Sir, we are privileged to have you today, and we welcome you for the insightful session ahead. Sir, we welcome you once again. Over to you, sir. Arun sir, can you hear us? अरुण सर, आपको आवाज आ रही है हमारी? अरुण सर, कुछ टेक्निकल प्रॉब्लम्स है सर के सिस्टम, सर के साइड से.
Am I audible, ma'am?
Yes, sir. Yes, sir.
Okay, fine. So, first of all, I want to say thanks to Krishna madam that she called me for such FDP program that has been organized by DTU for the educators, for the faculties and the research scholars. And today I have to deliver a lecture on AI that will cover the biasness and fairness in models. Before that, before I start with the presentation, I just want to make some conversation so that everybody will be aware about what is the biasness and how it relate in our daily life. So I want to display my screen first. Just a minute. Okay, fine. I think my screen is visible to all of you, right?
Yes, sir.
So what is the biasness? As you know that now every website, every software, every model is using the artificial intelligence. So how we can find out that there is some biasness or not? So if I say that when we are working in real life, we are having the social biasness, we are having the historical biasness, we have the data biasness. So data biasness can be seen using the data only. But if you want to see the social biasness, that how the AI systems or the websites are using the social biasness. So if I write some keyword here and I just find out that what we found, whether it is biased towards some particular thing or not. So if I write down the word nurse here, so if I want nurses here and I want to know the images of the nurses, then you can see just meaning, I will just remove the word of meaning, just only the nurse. So you can see most of the images when we vote for the nurse are the female nurse. I think only we are having only one male nurse here and one male nurse here, one male nurse here. Only three male nurses we are having. Rest of the nurses are the females.
Excuse me, sir. Excuse me, sir.
Yes, ma'am.
Sir, your audio volume is very low, sir. I think like, if you could increase, it will be better for you, sir.
Just a minute, I will get a headphone after. Just a minute. Is it fine, ma'am? Hello?
Sir, please go ahead, sir. Let us hear.
Is it fine?
Sir, a little bit more, sir.
Now I am using the headphone, so I think now it will be good. So what I want to say that when we are using the keyword nurse, then we can find out that the maximum images which we are having that are towards the female nurse. So there is a biasness towards the female. But if we write a word programmer, then what will happen? We found that most of the images are having the male programmer. Only there are one female is here, and rest are the male programmer. And the lower side we also have the maximum of the male programmer. So that is the social biasness we are having when we are having what? When we are having some AI models. So AI models is going what? As the Google is also using the AI, and their AI models are using the data that are used in their area, like in US or in Europe. So that's why most of the images which we are having that are towards the some particular genders, like the nurses are the female and the programmers are the male. So this is the thing which I want to tell you, that this is the biasness towards the particular gender. So this is just the thing which I want to tell you, that what is the biasness. Biasness means that we are towards a particular things, towards a particular features. That is the more principle in making the decisions. So Is my PPT is visible to all of you?
Yes, sir.
Okay, thank you. So now what we are having, myself, as the madam told you that myself, Dr. Solanki, working in Computer Science Engineering Department in Gautam Buddha University. This is the pictures of our university, that is the front gate. This is our school where we are having the offices, and we are having around 2,000 students in our school capacity. So before we start the theme, that is the biasness and the fairness. First of all, I know that you all know about the machine learning as you are in the FDP from 2 days. But as we can see that a man learns from the experience and the machine learns from the data, and whatever the data is fed into the machine, it follows that particular instructions. And that is called itself as a machine learning, that we are teaching the machine through the data. So there was a scientist, that is the author Samuel, who have given the term machine learning in 1959. So in the definition, I can say that machine learning is an application of AI. It gives devices the ability to learn from their experience and improve their self without doing anything. Because we have don't go to code on anything. We just put the data and we put a model, and after that machine will learn from their experience, from their data through the what is going on in the system. Like if you buy something online, and what will happen, you will found some new recommendations that you have to buy these things too. Like if I'm buying a laptop, then they can give me some recommendations that I should buy a mouse, or I should buy some devices, other devices. So that is something about the machine learning. So ML is a field of study that gives computers the capability to learn without being explicitly programmed. It means you don't have to program anything, but this way. System will learn itself. You will produce a model, and model will learn itself. So if you see the diagram, it is having some ordinary system, but when the system is converted AI enabled, what will happen? It works somehow. The half machine and half man look like a man, but work is done by the machine. And machine learning will learn from the data, and it predicts the recommendations, it gives the recommendations, predicts the outputs, and improve itself through the data, learn from and improve. This is happening when we are working on the machine. So these are the different 7 steps that are the data gathering, preparing the data, choosing a model, training, evaluation, hyperparameter tuning, and prediction. So where it comes, the biasing and the fairness, it comes from the number 2. When we are working on the data set, what data set we are taking, and whether there is some biasness in the data, and if there is some biasness, then we have to convert it into the fairness. That it will cover all the domains, all the features that are the principal features from the data sets. So machine learning itself of 3 types. We have already studied in these previous lectures that we are having the supervised learning, unsupervised learning, and the reinforcement learning. In supervised learning, we are having the labeled data, that is having the classification and relations models. In unsupervised learning, we are having the clustering, and in reinforcement learning, we have to make a system that will have some reward. When we are doing something good, it will get reward. And if the system is not working well, then we have to punish them, and the system will make it, it will improve itself using the reward and the punishment. That is the concept of reinforcement learning. Now, the thing that is algorithmic bias in the headlines. These are the different headlines that comes in different newspapers in UK and US, where the AI is now a prominent domain in different public sectors and in different websites, in different another whatever the system they are building. So if I read out some of the headlines, it is somehow the AI expert calls for end to use of racially biased algorithm. Racism is also a factor that can be used by the AI because for the data set. Second one is AI bias could put women's lives at risk, a challenge for regulators. Bias in AI, a problem recognized but still unresolved. Gender bias in AI, building fair algorithm. That is already told you that the nurses are the uh, females and the programmers are the male. So that is the gender bias. Millions of black people affected by racial bias in healthcare algorithms. Racial bias in medical algorithm favors white patients over sick black patients. So what is happening before I start the things? I want to discuss something that will happen in the US. There was a model that is called as the PRED that is used by the LA police, Los Angeles police that is using the PRED. So what is happening? PRED is completely based on the data set. What the data is given to the model, it works on that and give prediction that crime is going on here. So what is happening? There are some black people that living at particular some zip code. So initially the crime is going on there. So police just caught the black people and send them to jail. Again, so after some time, there is another black people that are still involved in some crime. So such type of data is fed into the model, and every time, what is going on? The most of the data of crime is fed into the system that belongs to the black people. But it is not that the black people is only doing the crimes. There are another people too that are also doing the crime. But as the data is fed from a particular chip code, and the system is working on the particular data set, and data set is saying that the crime is done by the black people, then what is happening? The patrol always tell the police that you have to go to that particular zip code because uh, their crime may be done. But irrespective of that, there is another zip code locations where the crime is also going on. But what is happening? Every time the police put the black people and put them behind the bars. So that were the problems when we are working on the algorithmic bias uh, in different AI models, AI classifiers. So what does bias means? Bias means that we are led towards a particular features, particular things, or we are in effect of something that will make the decisions. That is the biasness. Whether the features is doing good or not, that doesn't belong. But as the system tells that this features is or this data is giving some particular what I can say particular inputs. So we have to do such type of decisions. So if you see in this image, what do you think about it? I can say we have the watermelon, right? Then I can say there are lot of watermelon, slices of watermelons, or neighborhoods of watermelon, watermelon with the seeds. Anything else? Anything else which is coming into your mind? Anyone? Okay. But nobody can say that we are discussing about the red watermelon. We are not having in our mind that this picture is having the red watermelon. We are only having in mind that this is the watermelon. Why not the red watermelon? Because whatever we see, whenever we see the watermelon, that is always red. We have not seen the blue watermelon or the orange watermelon or the pink watermelon. We have not seen such type of watermelon. So our mind is set that watermelon is always the red. So if I see that that we are having the watermelon slices, watermelon with seeds, juicy watermelon, layers of watermelon, watermelon slices next to each other. But what about red watermelon? That doesn't come to mind. But when I see this picture, first of thing which comes in my mind is that this is the yellow watermelon. However, I have not seen the yellow watermelon yet. But there is some part of world where yellow watermelon exists. But we are biased towards the watermelon that is the red because we have seen that the watermelon is always red. So that is the biasness. So we have the yellow watermelon with seeds, juicy yellow watermelon. But every time we see that the feature that differentiate it to another, that is its color, that is the yellow watermelon. So we tend not to think of the contents of this image as a red watermelon because red is the prototypical color for watermelon, because we know that prototypical means that originally that the original color of the watermelon is always a red, so we never think about that. We have to say that this is a red watermelon. So we always think that this is a watermelon and with seeds, with slices and with likelihood to each other, putting nearby to each other. So that comes in our mind, but we have never gone about the color. So that is the general prototype we have made. So, so this prototyping is represents the concept or the objects. It means when we go for the data set of watermelon, then the color will be always a red, and we doesn't have the color as yellow color of watermelon. So that is the thing that we have biased towards the red watermelon that is of red color. So we can label the things, we can categorize, and we can simplify, make the groups there to. So we tend to notice and talk about things that are atypical. And the yellow is atypical things. Biases and stereotypes arises when particular labels and features confound decision whether human or artificial. Human biasness can be there because the human thinks that watermelon is always the red. And if I say the AI, if we have given the data to the classifier, then every time I have given the data or the images of watermelon that is the red color, so AI also decides that the watermelon is always the red color. But when we give a yellow watermelon to the classifier or the model, then it may be that it doesn't identify it as a watermelon. So in the same way, there are some facial detections classifier that is given by the Microsoft, or there is some face and the IBM. So you can see that there are 4 types of people are here: dark man, dark woman, white man, and white female woman. So what is happening? If you see that the percentage of identifying the darker female is very less. You can see that Microsoft is having 79.2% accuracy, Face is having 65.5%, and the IBM is having 65.3%. And as you see that the darker male is also having a less number of accuracy, but more than the darker female accuracy, that is 94%, 99.3%, 88%. But when we go towards the white male or white female, the accuracy is above the 90%. So why it is going on? Why this is biasness towards the white people, that the white people are having the higher percentage and the black people are having the lower percentage? Because the data sets that are used by the Microsoft or the Face or IBM, that are from the Europe. So that's why it is happening that the data set is not so full of peoples that are having all types of men and women, whether it's a dark man or whether it's a lighter or the white woman. So that's why it is happening that the black man and black woman is having the less number of accuracy, and the white man and white female is having the more than 90%. So in the graph you can also see that the American Indian female, that is of red color, and the female is and the American Indian male accuracy. American Indian male and female accuracy are the, it means this is the false match rate. If you see on the x-axis, that is the false match rate per 10,000. So this is the higher side when we go for the black one, and when we go for the white one, then the accuracy, if you see the white male accuracy, that is near to 0, and white female is near to 5 or 7. So that is the false match rate is very low for the white man and white female, and for the black people, the accuracy is less, and the false match rate is high. So if you see that this image, what is going on? You can easily see that there is a picture that is having a bride, because in US and in Europe, this is a woman, this is a bride who are going to marry. So that is particular dress. When we pass this picture from a CNN, that is the convolution neural network that can be used to classify, and we want to predict that what this picture is having. Then the CNN will predict that there is a bride having some dress, going for a ceremony. This is a woman, and as the dress suggests, that is going for the wedding. It's good. It is predicting all the correct thing. That's the good one thing that the CNN is predicting. But when we go for such type of images that comes from, I can say from the India, such type of brides we are having, then when this image passes through the CNN, what is the predicted classes? That there is some clothing, there is event, there is some costume, color is red. It may be there is some performance art is going on. Why? This is a picture of bride in India that is going to marry. So why it is going on? Why there is biasness towards the people that come from the Europe and the people that come from the Asia? That's the reason. This is the reason that the data sets that are already exist on Kaggle or any other data set repository, they are having the data that comes from their countries. So most of the data comes from the Europe. So that's why it is happening that when we pass such type of bride pictures, Indian bride pictures through the CNN, they are not predicting that this lady is going to marry, or that event that is going to celebrate, that is of some wedding type. So that is the reason. In the same way, if you see that this is the spices put it at a house in Europe, and we pass it through the CNN, then we have find out that this is having the seasoning, there is spice rack, and ingredients there. But when another picture of this type that is also having some spices, and this is spices from the Philippines. So when these pictures pass through the CNN, then what is happening? The objects identified, that is the product that is the yellow type, we can drink that, we are having the bottle, but there is nothing about that this is having the spices. So it means the CNN is not going good results, not going good predictions about the spices that comes from the Philippines, but it is giving good results for the spices that are coming from the Europe. So why it is going on? The same thing that is happening for the bride picture. The model is not trained on such type of spices that comes from the Philippines. So that's why it doesn't identify the objects. If you see that the another image, it is also having the bias correlation with income and geography. If you see that, it is saying that as the income increases, the accuracy is also increases. As you see that in the income in USD per month on x-axis, and accuracy is also on the y-axis. So if you see that 0.7 to I think 0.85, it is having the range, and the income coming from 55 USD per month to 10,197 rupees USD per month. So, is it true that the accuracy is increasing according to the income? Why it is going on? On the first picture of the world that is having a database of cocoa that is reflected here, you see that only some part of the world is taken of the where you can see the yellow part in the first picture. Only such type of data or the such region data is taken. So that's why this graph is shown the accuracy increases as the income increases. But when we take whole of the world called population, that is the that is the second picture where you can see that the minimum image is yellow and the maximum image is from the blue part. So you can see that this particular graph doesn't reflect what is really exists in the world. So it is biased. The graph is biased towards the Europe countries and showing their accuracy according to the income. That's why it is a biasness towards the uh, uh, countries that are having a higher income per month. So if I say that in every stage of AI cycle, there may be the biasness. But the most of the time, the biasness starts from the data. So first is the data, imbalances with respect to class labels, features, and input structures. You have not one good for all of these three things. Then we have to model, lack of unified uncertainty, interpretability, and performance metrics that are having the biases of some particular type, that training and deployment, feedback loops that premature biases, evaluation, learning bulk, lack of systematic analysis with respect to data subgroups and interpretation, human errors and biases distorted meaning of facts. But all of the biases start from the data. If you have taken a data that is unbiased, yeah, debiased, and having the fairness, then the biasness for the next 2, 3, 4, and 5 steps will be reduced. But there are such another types of biasness that can be in the there, but that can be removed. So if you see this picture, what is going on? This is an example that when we are having the biasness in AI, then we can have a bad results. So if you see here, I think you can see from my mouse that we are having a number of employees. Some are the male and some are the females. Females are from the red and males are from the blue. And when we interviewed such all of these, what is happening? There are some males that is a blue and the females that are here. Then there is some selective. It is 3 men's and 2 women's. And how much joined? Only 2 men's are joined. So what is the conclusion of that? Conclusion of this that when this particular data is given to the machine will see that at last only the male people has been joined to the company. So machine learning will predict that whenever we have such type of male and female combinations, then most of the chances are that the male will join the company and the females will not join the company. So it will predict or it will tell the higher authorities that you don't have to make interviews of the females. It means it is biased towards the gender that the male will join the company and female will not join the. So what is going on? AI is biased towards the male, not towards the female. So if this is going on and we put a system that will do all of these activities, then what will happen? It will always reinforce that we have to take the males. So as it is having a true value, if it is having the right value, then it is always reinforced. So, or it will have a feedback that always say that we have to take the females, take the males as a employee. So what we have to do? The solution of this that we have to debias such type of data set such that all male and female will have the equal opportunity to join the companies. However, the real pattern are of such type. So that is happening. So biasness in AI can give a result that is beyond the reality, that is not reflect the real world problem. So what we have to do, we have to understand that what are the sources and the types of biasness and what are the strategies that we can remove the biasness. So we have to discuss about it. So I think right now you are all able to understand that what is the bias, what is the biasness in AI, and now I am going to discuss that what are the different types of biasness we are having, and after that I will discuss about how we can remove such type of biasness that comes under the fairness. So if you see that this is the taxonomy of common biases. There are two types of taxonomy. First is data driven and second is interpretation driven. Data driven means that you are having a data set and data set is biased towards a particular features or there is some imbalance of the things. Interpretation driven means the results are there and on the results, on the basis of the result, we are biased towards a particular solution or particular thing or particular execution of something. So, but it is not an exhaustive list that all things covered in particular data-driven interpretation. There are a lot of other things, but these are the common biases that are. So, if you see that, the first I will start from the this one, the correlation files that is under the interpretation type. So, if you see here, what is going on? This is the correlation files. There is two terms, causation and correlation. Causation means the region by which something is going on, and correlation means that relationship among the two different features of the parameters. That is the meaning of the correlation. Whether is it possible that every two parameters will have some correlation? It may be or it may not be. It depends on the model, what if the model understand the things. So if you see here, what is this graph is saying? This graph is saying that we are having two parameters, one is in red, one is in black, and both are going to each other from 2000 to 2009. And the black one is showing that these are the persons who have computer science doctorate, and another one thing is about the y-axis that is not in that is the amount or I can say the revenue generated by the computer science doctorate. So if I put a correlation between the computer science doctorate who have attended a degree and what the revenue they have generated, then this is useless. So what is happening? But we have made a correlation. If a false correlation we have made among the computer science doctorate and the revenue generated. But this data doesn't have this data doesn't impact on the final results. But as this correlation is generated by us, generated by the system, it will put some false result to the output. So that's why if we have made a biasness from the correlation, then the output will have some impact. So that's why it comes under the interpretation driven biases. Second one is overgeneralization. What I can see, this is the expectations that what I can see that these all are the cups. But these are the generalized cups, or I can say there are only 5 types of cups. No, there are lot other types of cups are there. If you see that I can see the cups from different angles. So I have what I have done. I have overgeneralized the things that the cups are only of 5 types. But in reality, when I see the cups are of different types and from the different angles. So what is happening? The result will be degraded when we test the cups from the reality side, because we have trained our model on the expectation type that are the 5 types. So that is the overgeneralization of the things. So the result is there, but that result is not accurate as per the reality. If you see here, there is a keyword that is used as the distribution set, data set distribution. So what is the data set distribution set? what is happening when we are having the data and that data set changes according to the time. And what is going on? Whether you have not updated the data and you are testing the recent things on the old data. Old data means that a model that is having that has been trained on the old data sets. But what is going on? If you see these images, that the first one is the training part and second one is the testing part. In 2002 in America, that satellite image is having a shopping mall here. Africa, it is having the residential unit here. In Europe, there is nothing. But what is going on? But what is going on in 2016? The image which we have taken, which we have tested, that is having the recreational facility. But your model has not been trained for recreational facility. So what will happen? It will never identify that this is a recreational facility. So what is going on? It is biased. It is biased on this particular data, that is the old data, and this is not the shifted on the new data. So to make our system on the fairer type, the data set should be updated and the model should be trained on the data set that has been shifted from 2002 to 2024 or another timeline, whichever you want to choose. Second thing is that is a data-based, data-driven biases. If we are having the biases due to the class imbalance, if we have the three classes A, B, C, that is in reality, but when we put this classes into the data set, what will happen? We have increased the prominence of class A, decreased the class B, and C is the same. So what will happen? It will not give the accurate result because you have changed the frequency in data set, whatever you are having in the real. So this is the model accuracy, but this is not the good accuracy. So that's why it doesn't. So what we have to do? We have to make that class are having the fair performance. If C is having higher side, you see that C is on the higher side, and if we make B and C as a combined one, then find out that is the average of the things. So you can see that here the model accuracy will be the, because we have given the I can say that we have given the utilization of every class in a good manner. If we are having a classifier and classifier is having two portions or the two things, this is the binary classifier 01. So what is going on? It is having some orange part and this is having some blue part. And when we want to put a I can say hyperplane between these two, or I can find out the differentiate between these two, then I will put it on the middle of the blue and the orange. But what is happening? The condition is that for every single orange point, we will have the 20 blue points. So what is going on? We have the maximum number of blue points in our model. If we are having such type of problem, then what will happen? The line will be shifted. Why? Because we have to take decision according to the majority, and majority is saying that the blue on the upper side, because we have the gradient, and the gradient moves as the point moves, as the decision moves. If you see that in the next one, what we are having, we have the incremental updates made to the classifier during learning, because learning says that all of the blue points should come inside the blue area. And you see that we have covered the 4 blue points, and now the decision is going towards the blue, not towards the orange. If you see that more, we have found one more blue point, then we have to move our decision towards the blue. And now what is happening? For every 20 we have a orange point, but orange is itself a single number and we are having a 20 blue point, so the decision will be made according to the blue point, not from the orange point. So what is happening in learning? We have told that blue part is having most of the samples are coming from the blue part. So whatever we are having a orange part, but every time it will show that it is a blue, not the orange, because the decision are taken according to the blue, not the orange. So that is the biasness when we are having the class imbalance, because we are having two classes. Two classes should have the equal points of blue and the orange, but what is happening, we have imbalanced the class and the decision will be taken according to the majority of the classes, that is the blue. The another case study which we can have, this is that one, first one was only the symbolic representation, but if you want to make it in the live example, then we can see that this is the class imbalance. Why it is the class imbalance? Let we are having the 100 people, and in 100 people only one people is having the cancer. If you see that the number is 3.19 per this is the 10 lakhs. 1 lakh. From in 1 lakh only the 3.19 people will have the GBM, that is some such type of cancer. So what is happen when we doesn't have the data of the people that are having the cancer, then how we can identify that this person or this person or this person or some test data person is having the cancer? Because 99.97% data comes from the healthy people and only the 0.003% data is coming from the cancer people. So every time when there is some cancer people, it will always say that is a healthy people, because such type of data is not trained by the machine. So that is the class imbalance. It means we have not given the proper training of the different types of data to the machines. That's why it always says that this is the healthy people. It means it will put you in danger while you are having some cancer. So we want to another symbolic representation of class balance data, that is about the batch selection. If you see that if we are having the 1:1 class ratio, then we have no problem. It's good, because we can take the decision on the basis of both. As two blue are in orange and two orange are in the blue, then it is equal. If you see that we have to change the or update according to the region where we can put the blue and orange in the equal part, or both will have the same power to make a decision. So if you see that such type of lines can be drawn between the orange and the blue to make the incremental updates as the number of points increases, as the number of data increases, the decision will be changed according to that, and the data will be good. So if you see that the lines has been changed, or the decision has been changed. Blue is in blue and yellow, orange is in the orange, right? So if we are having a class and the class is having some weight, if you read about the neural network, there is a term of weight. That weight is given to the particular input. So in the same way, we are having a class and weight is also given to that. If you see that the class A is having some such type of weight, class B, however, it is having less number of values but weight is given higher, and C is having the higher number of frequency but weight is the low, and this is the contribution to this particular output. So that according to the weight, the contribution will be there. If you increase the weight, then a contribution to make the decision is also increased. So another example is that if we are having selection, if you want to make the results on the size of the dots, if you see that if the size of the dots of the orange is increased and the blue is decreased, then what will happen? the training will be done on the basis of the weight, and the weight of orange is higher and the weight of blue is lower. But as the blue is of much size and having weight is less for individually, but when we total of all the weight, then it will equal to the ball. So the output or the test data, when we go for the test data on this particular weighting, then what will happen? It will give the good results. This was about the simple class base, but what will happen if we have the biases in the features? If we have the faces we are having, and what will happen? We are not having the non-faces. If you see here, there are two images. First is having the faces, and second one is having the non-faces. But it may be happen these non-faces are having such type of features that equal to features of these faces. So it may be happen that these non-faces will be featured as a feature when we go for the output. So there may be another biases that is hidden within each class, and that can be more dangerous. If I say, if this is related to the first example which I have given you, that the black woman and the black man is having the less number of accuracy, while we are having the higher number of accuracy when we are having the white man and the white people. So this is the thing, there is some biases are there. So if we want to discuss a facial detection hidden biases using a case study, then we can see that in the real world there are the maximum people who are having the black hair. After that there are some people who are brown hair, and there are some people who are the blonde, and red hair are a less number of people that are having the red hairs. But what is happening? There is a standard data set that is known as a gold standard data set. What it says? It says that there is a minimum number of black hairs. After that we have a lot number of brown hair, and there is a lot number of blonde people, and red hair is a less number of people. So what is happening when our system is run or is trained on gold standard data set, it will maximum give an output that the pupil is having whether the brown hair or the blonde hair, because it is not a balanced data set. This is the balanced data set that we have given input or equal weightage to each and every pupil that is having the black, the brown, the blonde and the red. So this is the balanced data set. So if I suggest which type of data set we have to use the balanced data set. The example of each type of class which you are using, that should be equal to each and every model training. So when it goes through the CNN whole standard data set, what is happening? It is saying the black number accuracy is low, brown and blonde is maximum, and there is a lot less number of red people. Why it is? Because whatever we have fed it into the training, that will be displayed in the output when we go from the test. So how we can improve the fairness, or how we can minimize the biasness. So there are some biased model data set we are having. So what we have to do, we have to remove the features that are giving the biasness, and that will improve the fairness and mitigate the bias. So you see that it is having both sides equal. In the same way, if we have the biased model data set, we have to add some signals that will remove the biasness or resolve the biasness issue, and after that we will reweight signal improves fairness. So what we can do, if we have the biasness, we have to add some weightage to some features that will increase their users to reach on a decision. So if I say that what is the bias and what is the fairness means, it generally, if I say, if a decision is not changing, while you are adding a sensitive feature to the input, then it means it is a fair thing. But when you add a feature to the data set or to the model, and according to that the output is changing, then this is the biased towards that particular input. So if you see the content which has been written that reflect the same, that we have a classifier outputs decision should be the same across sensitive characteristic given what the correct decision should be. So it should be same across sensitive characteristics. A classifier is biased if its decision changes after being exposed to the additional sensitive features input. As you input the features and the decision is changing, it means it is biased. And for the fair, it is fair with respect to variable z. The value as the z changes, the value should not be changed. So if you see the example here, the fairness meaning whether we have having the z0 or z1, the value is y is always 1. So it doesn't impact the system doesn't impact on this particular variable whether it is a 0 or whether it is 1. The result is same, that is the y. So that is the fairness. So fairness, evaluation of biasness and fairness can be done on the two types. First is disaggregated evaluation and second is intersectional evaluation. So disaggregated evaluation means that we have to evaluate performance with respect to different subgroups. We are evaluating color and putting shape as a constant, or we can evaluating shape putting color as a constant. And intersectional evaluation can be done how we are measuring the blue color shaped with the orange color shape. If we are doing this way, then we are using the intersectional evaluation because it is having the evaluation of performance between this group and this group. It means there is a fairness because we have given the equal opportunity of color and shape to both of the classes. So there is a adversarial multitask learning to mitigate bias. Mitigate means को कम करना, reduce the biases. How we can do that? If you see that we have a input X that followed from some hidden layer. Input is given to the hidden layer, and it has to predict whether it is having task Y or not, and predict the attribute that is giving the biasness to the system. So what is going on? We have find out that this particular attribute is given the biasness to the system. So what we have to do, whatever the biasness is given by this particular attribute Z, that should be negative. So there we have to follow up some negative gradient. It means we have to go back to the previous system or using because there are some biasness due to the Z. So say the same thing is reflected here, that we have to specify attribute Z for which we seek to mitigate bias. So we have to find out that whether the Z is biased or not. Jointly predict output Y and Z. Y and Z ka we have just find out the output of Y and Z. Two discriminator output heads Y and Z. Z is a sensitive attribute. We have the train this adversarially predict sensitive attribute Z. This has been predicted. Negate gradient for Z head. Whatever the biasness is given by the Z, that is negated. Remove effect of Z on task decision. It means whatever the decision is taken due to this sensitive attribute, that should be removed when we negate the gradient. If you see the same example, such type of example, but we using some data, that we having a he or she, he is to C and doctor is to who will be the doctor? Who will be the doctor? When we have the bias data, what we find out? We have the bias data, we find out that we have the nurse, nanny, fiance, maid, fiance, mother, fiance, dentist, woman, and this is the similarity. And when we de-biased, it means the effect of Z has been negated, and the data set becomes the de-biased, then the similarity has been changed. That is 1.01 to 0.70, 0.90 to 0.68, and all of these things can be happen. So this is about the biasness and how we can remove the biasness and come to the fairness. Now I want to give you an example that how the machine learning is working through some data models. If you see that, just a minute. Uh, we are having an okay, fine. So we are having a website that is having the teachable machines that is available. That website is given by the Google. So what it is having. I want to use some biasness here, whether there is some biasness or not. If I want to go for the some image project, is it visible to all of you? Is the web page visible?
Yes, sir.
Okay, fine. So you can see that it is the teachablemachine.withgoogle.com. That is the website. So what we have to do, we have to collect some sample. So I am having some sample like I am having the mobile phone here. Did you see that? This is the mobile phone, right? I think is it visible? Now I am taking the samples. I have taken how much samples? I have taken around 196, 276 sample I have taken, right? Now, okay. Another sample I have taken of I am having a key. And 4 samples are taken, right? I have made the class imbalance. Now, what is going on? We are training the data set. It will take time about 2-3 minutes. Right? If you see that, when I put the key, I have given the key to check, but it is saying that this is a mobile phone. Why? When I am putting a mobile phone here, it is given it as 100% that it is right. And when I put both the things, it is having. If you see that it is changing, but with the minimum number of percentage, it changes. Class 2 is coming, but it comes very few accuracy, and it reflects only 5 to 7% maximum, as it is not in number. Because what is happening, I have taken only the 4 samples, and what is happening again? What I do, I will again increase the sample, right? What is happening now? I am increasing the sample. Come to focus. Again, the model is training. See, I am also part of the training because my photo is also in the training. But if you see that now, what is happening? It comes around as the size is very good and the picture is not so much visible here. But it goes from 94, 1900. Because the mobile phone and these two are the similar types of the system. You see that mobile phone, there is the 100%, no problem there. And when you go for the key, everything that is also very from 0 to 100. So that is the biasness. I think now all of you are clear that what is the meaning of the biasness and how the biasness can be removed when we are having a balanced data. When we are having a balanced data, then the biasness can be removed easily. So that was from my side. Thank you, ma'am. Any questions? Okay, Krishna ma'am, are you there?
Yes, sir.
Okay, ma'am. Thank you so much. So much.
Is there any query or question participants do you have? आई थिंक कोई क्वेरी नहीं है किसी की.
So now we conclude the session.
Yes, sir. Yes,
Ma'am, I need to have a clarification. This biasness and fairness in AI, like how is this going to influence me as a teacher or the teaching learning process which we are carrying out?
Okay. In real time, if I want to give an example, in your class there are two students. And what is going on? Or I can say that two groups of students are there. One group is a group that is having a low performance, and one group is having the higher performance. What is going on? You have make a rule that the group who is having the low performance will will do the homework daily, and I will check the homework, right? But you have not make such rule for the people who are having the high performance. When a person from the low performance is not doing the homework, then you will punish him. You know that. But it may be happen that a person, a student from the high group is not doing a homework, but you don't know whether the homework is done or not done by the student that is having a good marks. So that is your biasness towards the persons, towards the students who is weak in the student. This is the one of the example in which you can say that there is biasness among the students, right?
Yes, sir.
any other queries or questions? Okay then.
Okay. Thank you. I am saying them. Thank you so much.
At the end of this enlightening session on bias and fairness in AI systems, I would like to take a moment to express our heartfelt gratitude to Dr. Arun Solanki, sir. Sir, your deep insights into the critical issues surrounding bias and fairness in AI have been incredible. Your experiences have provided us with a comprehensive understanding of challenges and also the solutions in the important areas. The knowledge you have shared today will undoubtedly contribute to our ongoing efforts to develop more equitable and just AI systems. So we are really very thankful for your time and efforts, sir. Thank you so much, sir.